Imagine waking up tomorrow to find that New York City has vanished beneath 70 meters of seawater. London gone. Shanghai submerged. Tokyo. Just a memory beneath the waves. This isn't science fiction. This is the mathematical certainty of what happens when 26.5 million cubic kilometers of ice decides to return to liquid form. And right now, as you're watching this, that ice is melting faster than at any point in human history. Before we dive into this catastrophic scenario, drop a comment below telling me which city you're watching from, because by the end of this video, you'll know whether your hometown survives or becomes the next Atlantis. And trust me, you'll want to stick around to find out exactly what happens when Earth's frozen reserves completely disappear. Welcome back, everyone. I'm your Cosmic Science Guide, and today we're exploring one of the most dramatic transformations our planet could possibly undergo. We're not just talking about rising sea levels here. When all of Earth's ice melts, we're talking about a complete planetary reboot, a fundamental restructuring of climate systems, ocean currents, geological forces, ecosystems, and human civilization itself. Now let me be clear from the start. This scenario requires extraordinary conditions that push the boundaries of what's physically possible in the near term. We're looking at a global temperature increase of 8 to 10 degrees Celsius above current levels. To put that in perspective, that's far beyond even the most extreme climate predictions for the next century. We're talking about Earth resembling the Eemian period from 125,000 years ago, but significantly hotter and completely destabilized. For this to happen, every single ice formation on Earth would need to melt. The Greenland ice sheet gone. The Antarctic ice sheets both west and east completely liquefied. Arctic sea ice non-existent. Every mountain glacier from the Himalayas to the Andes vanished as if they never existed. And we're assuming no geological or climatic forces intervene to slow this process down, which is admittedly a science fiction assumption, because nature typically has negative feedback mechanisms that would resist complete melting. But let's suspend our disbelief for the next 15 minutes and follow this scenario to its logical conclusion. Because the physics, chemistry, geology, and climate science behind what would happen is absolutely real, even if the timeline is speculative. The first and most obvious consequence happens almost immediately. Well, immediately in geological terms, meaning within years to decades. The global sea level rises by approximately 66 to 70 meters. Let me help you visualize what 70 meters actually means. 70 meters is enough water to completely erase from existence cities like London, New York, Shanghai, Kolkata, Bangkok, and Ho Chi Minh City. The entire nation of Bangladesh, mostly underwater. The Maldives, Tuvalu, and countless Pacific Island nations completely wiped off the map. The Netherlands. They'd need to build dikes that would make their current engineering marvels look like sandcastles. Florida. Say goodbye to the entire peninsula. California's Central Valley. That becomes an inland sea. The Mediterranean expands dramatically. The Amazon Delta becomes a vast oceanic bay. We're not talking about inconvenient flooding here. We're talking about the forced migration of billions of people, potentially 3 to 4 billion humans, displaced from coastal zones. The largest mass migration in human history, dwarfing anything we've ever experienced. Entire nations would cease to exist geographically. Earth would literally have a new map, new coastlines, and possibly new countries emerging from what is currently seabed. But here's where it gets really interesting from a scientific perspective. When you dump that much fresh water into the ocean, remember, ice is frozen. Fresh water, you dramatically alter the salinity of the world's oceans. Ocean salinity isn't just about taste, it's fundamental to how ocean currents work. The Atlantic Meridional Overturning Circulation, or AMOC, which includes the Gulf Stream, operates on a system called thermohaline circulation. That's a fancy way of saying it's driven by differences in temperature and salinity. When you flood the Atlantic with fresh water from melting Greenland ice, you disrupt this entire system. And here's the paradox that confuses a lot of people. Parts of Europe could actually get colder, not warmer, despite global temperatures rising. The Gulf Stream currently carries warm water from the tropics to northern Europe, keeping places like Ireland and the UK much warmer than they should be at their latitude. Shut that down, and London's climate could start resembling Labrador, Canada. We've seen this happen before in paleoclimate records. It's not speculation, it's documented geological history. Meanwhile, the climate itself enters a state of chaos. Warmer oceans mean more energy in the atmospheric system. More energy means stronger, more frequent hurricanes and typhoons. Rainfall patterns become extreme. Some regions experience devastating floods, while others face prolonged droughts as the Hadley cell circulation intensifies. Deserts expand. The monsoon systems that billions depend on for agriculture become unpredictable. Earth enters a period of climatic instability with no stable equilibrium point in sight. Now, let's fast forward through the next few centuries and examine what happens as these initial changes cascade through interconnected systems. The global ecosystem begins to collapse in waves. In the oceans, the combination of increased acidity from all that CO2 we've been pumping into the atmosphere and sudden changes in salinity creates a die-off event for shell-forming organisms. Oysters, clams, mussels, coral reefs, they all depend on specific chemical conditions to build their calcium carbonate structures. Change those conditions too rapidly, and they simply can't survive. When these organisms die off, the entire marine food web collapses from the bottom up. Phytoplankton populations crash. Fish stocks plummet. Marine ecosystems that took millions of years to evolve can unravel in mere generations. On land, the polar regions currently home to uniquely adapted cold climate biodiversity transform into temperate zones. Species that evolved specifically for Arctic conditions have nowhere to go. There's no colder place to migrate to. They face extinction. The permafrost, that permanently frozen soil covering vast areas of Siberia, Canada, and Alaska, thaws completely. And here's where we encounter a terrifying positive feedback loop. Permafrost contains enormous quantities of organic matter, dead plants and animals that have been frozen for thousands of years. When it thaws, bacteria wake up and start decomposing all that organic material, releasing both carbon dioxide and methane, a greenhouse gas 84 times more potent than CO2 over a 20-year period into the atmosphere. We're talking about hundreds of gigatons of carbon. This additional greenhouse gas accelerates warming even further, creating a runaway effect that pushes temperatures higher than our initial assumptions. But the changes aren't just chemical and biological. The geology of the planet itself begins to shift. You see, those massive ice sheets covering Greenland and Antarctica represent trillions of tons of weight pressing down on the Earth's crust. When that weight suddenly disappears, the crust responds through a process called isostatic rebound. Essentially, the land bounces back up like a compressed sponge, expanding when you release the pressure. This isn't a gentle process. As the crust adjusts, it triggers increased earthquake activity. Volcanic systems that have been dormant can reactivate. We'd see a temporary but significant increase in seismic and volcanic activity, particularly around Greenland, Antarctica, and Iceland. The planet is literally reshaping itself in response to the loss of ice. For humanity, the most immediate challenge is the abandonment of coastal megacities. New York, Tokyo, Mumbai, Ho Chi Minh City, Jakarta, Manila. These aren't just cities. They're the nerve centers of global commerce, finance, technology, and culture. When they go underwater, global supply chains have to completely reorganize. Ports relocate, trade routes change. Entire industries relocate inland. Humanity enters an era of interior settlement, moving away from coastlines that have been the centers of civilization for 10,000 years. Now let's take an even longer view. What does Earth look like? 1,000, 5,000, 10,000 years after all the ice has melted, geography itself transforms in surprising ways. The Great Rift Valley in Africa, which is already slowly splitting the continent apart, floods with seawater, creating a vast inland sea stretching thousands of kilometers. East Africa becomes an island. The Mediterranean expands. The Black Sea connects more directly to the Mediterranean. The Persian Gulf becomes dramatically larger. The geography students learn in school would be completely unrecognizable. The Arctic Ocean, no longer capped with ice, becomes capable of absorbing heat directly from the sun. Without that reflective white ice surface, which currently bounces about 80% of solar radiation back into space, the dark ocean water absorbs that energy instead. This drives temperatures in the polar regions even higher. Instead of frozen wasteland, the Arctic becomes a temperate forest zone. We're not speculating wildly here. Paleoclimate evidence tells us this has happened before, during warmer periods in Earth's history. The global climate eventually stabilizes, but at a level 8 to 12 degrees Celsius warmer than our current baseline. This might sound abstract, so let me give you a reference point. Earth was this warm during the Eocene epoch, roughly 50 million years ago. What was that world like? Crocodiles lived near the North Pole. Palm trees grew in Alaska. Tropical rainforests extended to 45 degrees north latitude, that's roughly where Minneapolis or Milan are today. There was no permanent ice anywhere on the planet. For any humans still surviving in this transformed world, and that's genuinely uncertain. Given the scale of these changes, civilization would have reorganized completely. Cities would exist primarily on high plateaus and mountain ranges. The Ethiopian highlands, the Tibetan Plateau, the Andes, the Rockies. These become the new centers of human population. Agriculture would have migrated with the climate zones. Technological priorities would shift entirely toward cooling systems, desalination, and long-term survival infrastructure. It would be a post-coastal civilization adapted to a high-temperature version of Earth. So how likely is this scenario? Let me give you my scientific assessment on a scale of 1 to 10. Physical feasibility, meaning could this actually happen according to the laws of physics? I'd give that a 4 out of 10. It's entirely possible over tens of thousands of years following natural cycles. Earth has been this warm before. It will probably be this warm again eventually, even without human influence, given enough time. Feasibility within the next few centuries. 1 out of 10. It's simply too fast. You'd need non-natural conditions to accelerate ice melt to that degree in such a compressed time frame. But here's the uncomfortable middle ground: feasibility if humanity continues burning fossil fuels without control for 2,000 to 5,000 years. 6 out of 10. That's actually within the realm of possibility if we fundamentally fail to change course and maintain industrial civilization for millennia without transitioning away from carbon. Here's the thing: people need to understand from a geological perspective. Earth doesn't need ice to exist. Our planet has spent most of its 4.5 billion year history with little to no permanent ice. The current ice age, yes, we're technically still in an ice age because we have permanent polar ice, is relatively recent in geological terms. Earth will be fine. The planet has survived much more dramatic changes, but human civilization, that's built entirely on the assumption of stable coastlines, predictable climate patterns, and the current distribution of ice, land, and ocean. We're the ones who need Earth to stay the way it is right now. So here we are, exploring what happens when Earth loses its frozen reserves. This isn't a Hollywood disaster movie. It's a physics problem, a chemistry problem, a geology problem, and a climate problem, all interconnected, describing what occurs when a climate system gets pushed beyond its stable state. Earth won't die. It will simply change following the language of nature, responding to new energy balances and chemical equilibria. The planet has transformed countless times over billions of years. This would just be another transformation. But our civilization isn't billions of years old. It's fragile, recent, and entirely dependent on conditions that have existed for only the last 10,000 years, a geological eye blink. We're living in a moment of planetary balance, and that balance is far more delicate than most people realize. The ice is melting right now, not at the catastrophic rate we discussed today, but it is melting. Every year, Greenland loses approximately 280 billion tons of ice. Antarctica loses about 150 billion tons. These aren't abstract numbers. They're measurements. They're happening. The scenario we explored today is the endpoint if those processes continue unchecked for long enough. So the next time you see a glacier in a photograph or a documentary about polar bears on melting ice, remember you're looking at a planetary thermostat. You're looking at Earth's cooling system. You're looking at the infrastructure that keeps our world habitable for 8 billion humans and countless other species. And now you know exactly what happens when that thermostat breaks. Thanks for watching. Drop a comment and let me know. Did your city survive the melt? And if you found this fascinating, stick around for the next video, where we'll explore what happens if Earth's magnetic field suddenly disappeared. Trust me, it's even wilder than what we covered today. Until then, stay curious, stay scientific, and remember, we're all passengers on Spaceship Earth.